All right, today we're going to look at 11.4 and we're going to simplify rational expressions. Before we start doing that though, does anybody remember what a rational number is? If we're talking about simplifying rational expressions, we need to be able to recognize a rational expression. Does anybody remember what a rational number is? Okay. All right, what if you look at all the examples that you just wrote down? What are every single one of the examples that you wrote down?
They have an X.
They're fractions. So a rational number is any number that can be written in fraction form. Okay? What's an expression? Because we've learned about expressions and we've learned about equations. What's the difference? Somebody raise your hand. What's the difference between an equation and an expression? Kennedy.
Expressions don't have equal signs.
Do any of your problems in your notes today have equal signs? No. So these are rational expressions. Okay? Expressions do not have equal signs. And these are all in fraction form. So today we're going to simplify rational expressions. All right? In order to do that, we can clearly see at the top underneath the instructions where it says factor the numerator and the denominator completely. Okay? Factor the numerator and the denominator completely. All right, so let's look at letter A. Letter A is pretty simple. It's a pretty standard fraction. We have 5x in the numerator and we have 25 in the denominator. So the first question we have to ask ourselves on every single one of these problems, can we factor the numerator and or the denominator? So look at your numerator, it's 5x. Can I factor 5x? Now, remember what factoring is. It's pulling out a GCF. It's doing the x method to where we end up with two binomials. So there's a lot of, if it's a difference of squares, we can factor it. So there's a lot of different ways we learn to factor. But looking at 5x, can we do anything to 5x to change it? No. Okay, and here's something important that you should probably add into your notes. Monomials cannot be factored. All right, one-term problems cannot be factored. So you should never, ever, ever say yes when I say, can 5x be factored? Because it's a monomial. There's no way to factor it. All right, 25, the denominator. Can 25 be factored? No, it's a number. All right, it's 25. It's a monomial, so it cannot be factored either. So 5x over 25. Now, go back to elementary school when you learned how to reduce fractions. Does everyone see that we have 5 over 25? So what goes into both 5 and 25? 5. So 5 is going to cancel and become a what? 1. And 25 is going to cancel and become a 5. Because 5 divided by 5 is 1, and 25 divided by 5 is 5. So my final answer is x over 5. Now, can I have the 1 in front of the x? Absolutely, if you want to. Is it necessary? No, it's not. All right, so that one's pretty simple. We just look. We can reduce or simplify 5 over 25. X doesn't have anything to simplify with, so we leave it. So x over 5 is our final answer. Now, look at letter B. Letter B gets a little more complicated. Look at the numerator. Can we factor 2x any further? No. Look at the denominator. We have x times x plus 5. Can we factor the denominator any further? Maybe, okay, because we have a binomial this time, and so anytime we have a binomial, we're going to stop and take a look. So we're looking at x plus 5. Can x plus 5 be broken down or factored any further? Okay, there's not a GCF. It's not a difference of squares, so it cannot be factored any further. So now the question comes into play, what can be simplified in this problem? Does anybody think they know what we can simplify in this problem? Noah?
Could you distribute?
All right, if you distribute, you're going to take it to x squared plus 5x. And remember, it says factor the numerator and denominator completely first. So would it do us any good to go the wrong way? Distributing would take us the wrong way, so no, we're not going to distribute. We're looking at the numerator and the denominator, and we're seeing if there's anything that will simplify. All right, which x's are you talking about? All right, and the x in the numerator? All right, question for you. What if he had said the x in the numerator and this x? That would be incorrect. All right, and here's why. And this is the thing you've really got to get into your mind today during this lesson. When I'm looking at a binomial, all right, I cannot separate it in my brain. That is not an x and a positive 5. It is a piece. If I'm looking at this as a puzzle, all right, let's look at letter B as a puzzle. Here are the parts of the puzzle. 2x, actually, that's not even true. 2 is a part of the puzzle. X is a part of the puzzle. This x is part of the puzzle. And the binomial is stuck together. I cannot separate it in my mind. X plus 5 is its very own piece of the puzzle. All right? So I can't ever simplify the x and not simplify the 5. It just doesn't work that way. So Noah, you are exactly correct when you said the x in the numerator and the x outside of the parentheses. Those x's, because anything over itself equals 1. So we're left with 2 in the numerator and x plus 5 in the denominator. Awesome. All right. Let's do a couple more and then I'll let you ask questions. Look at letter C. Reagan, anything in the numerator that we can factor. We can pull a GCF out. We can factor it further. Anything in the numerator. All right. Why the 6? Remember, this binomial, you can't look at it separate. It's its own piece of the puzzle. So can we break down x squared plus 6? No. Our initial thought might be yes, because that's an x squared, but is that the difference of squares? No. So I can't factor it. And is there a GCF in both the terms? No. There's an x squared in the first term and a 6 in the second. So there's absolutely nothing that I can do. What about the denominator? X squared. Can that be factored down any further? No. All right. So who thinks they know what will simplify in this problem? Raise your hand if you think you know. All right. So let me teach you how to do this problem. First of all, I want you to bring down the x times x squared plus 6 because nothing about that numerator is going to change. But let's expand x squared because I think this is, for those of you who are visual, this is going to be the best visual picture I can give you. If I have x squared, how many x's do I have? So let's write that as x times x. Now do you see anything that will simplify in this fraction? Ellie, do you see anything now that we've put x times x in the denominator? Anything that we can cancel out or simplify?
The x outside of the parentheses.
Okay.
What if the x
Very good. I've got 1x outside the parentheses, and I've got 1x in the denominator, and anything over itself equals 1. So if I cancel that one set of x's out, what am I left with as my final answer? X squared plus 6 over x. Now remember, I cannot simplify the x squared and the x because that binomial is stuck together. I can't look at it as separate pieces. All right, look at letter D. Janicia, anything I can do to x plus 4, the numerator? Can I factor it any further than it's factored? All right, anything I can do to the x, the denominator? No. So, does anything simplify in this fraction? All right, she says no. Anybody disagree with her? You sure you disagree with her?
Yes.
All right, why?
Well, then the x cancel.
Hold on. X plus 4 is part of a binomial. Can I look at a binomial as separate pieces? No. So, she is exactly correct. This one cannot be simplified. And that's all you have to write down if you run into this in your homework. All right, it cannot be simplified. It is in its simplest form. So it cannot be simplified. All right, now I'm okay with that mistake, Noah, because it does make us stop and think. But again, a binomial is its own piece. I cannot look at it as two separate pieces. It's one whole piece. Okay, let's look at letter E. Now we're getting into this part where we can start to factor things. Can we do anything exact size more to 15x? No. All right, what about 5 minus 10x? Yes, so here's what I'm going to do. I'm going to go ahead and bring down the 15x because I know I'm not going to change it. But I do have to do something to the denominator. What do we have in the denominator? We have a GCF. Does everybody see that? So that's why I'm going to bring the numerator down and we're going to write the new denominator underneath it. What is my GCF, Zach? 5. So I've got a 5 on the outside of the parentheses, and now I'm going to start a set of parentheses. Remember, we divide each term by the GCF. So what is, Zach, keep going. What's 5 divided by 5? 1. So I got a 1 in parentheses. What is negative 10x divided by 5? Negative 2x. And I close the parentheses. Now, can 1 minus 2x be factored any further? So we factored everything we can factor. Now we look for things that will simplify. Jacob, do you see anything in this problem that we can simplify? Good. What goes into both 5 and 15? 5. So 5 goes into itself once, and 5 goes into 15. So, Jacob, what am I left with for my answer? Good. Can I leave 1 minus 2x in parentheses and put the 1 on the outside? If I wanted to. Sure. But do you need to? No. All right, very good. So you see, it looked at the beginning like we couldn't cancel. But because we factored down the denominator by pulling out the GCF, then we were able to simplify the problem. All right, any questions? All right, let's look at letter F. Letter F. Jenny, numerator. Anything we can do to factor the numerator? What?
2.
Okay, we have a GCF of 2. Just 2? All right, does anybody disagree that the GCF should be something other than 2? Kennedy.
2x.
Very good. Look, there's an x squared and an x. If every term has the same variable, then we can also pull out a variable GCF. So Kennedy, it's going to be x to what power?
1.
Good. We always pull out the smallest exponent. So if we divide each term by 2x, Kennedy, go ahead and tell us what we have left.
X minus 3.
Good. 2x squared divided by 2x leaves us with 1x. And then negative 6x divided by 2x gives me a negative 3. All right, good. Anything I can do to 6x squared in the denominator? No. 6x squared cannot be factored. All right, but let's look at the 6x squared. What do we want to do with that x squared to kind of help us visually? Okay, x squared is how many x's? 2. So we've got x times x. All right, Ajane, what will cancel first now that we have factored everything down? Listen, I always want to start by looking at the numbers. Can I simplify the fraction? All right, 2 over 6, right? What goes into both 2 and 6? 2. 2 goes into itself once, and 2 goes into 6 3 times. All right, now look at your variables. Do you have any variables you can cancel? Okay, I've got an x outside the parentheses in the numerator, and it can cancel with one of those x's in the denominator, because anything over itself equals 1. All right, so what does that leave me with, Reagan, as my final answer?
1 parentheses x minus 3.
Okay, you can put the 1 in the parentheses if you want. You don't have to, though. So x minus 3 over
3x.
3x. Awesome. Now, before you're tempted to cancel out the 3's and cancel out the x's, remember, x minus 3, that binomial, is one piece. It cannot be looked at as 2 separate pieces. So x minus 3 over 3x would be my final answer. Okay, great. Any questions? All right, look at letter G. Now, this is where it gets fun, unless you still don't know how to factor, and then you're not going to think this is fun at all. Okay, look at our numerator. Can we factor? It's a trinomial. Can we factor this down any further? Yes, okay. Now, good news is this is a simple factoring problem, because what is the leading coefficient? Everybody should be answering me on this one. Okay? What is the leading coefficient?
1.
Good, it's a 1. So this is a simple factoring problem. So we're going to do our x method. And we're just going to focus on the numerator right now. So Izzy, what goes at the top of my x?
1.
And what goes at the bottom?
Negative 20.
Awesome. We need factors of which one of those?
20.
20. So 1 times 20,
20.
2 times 10, and 4 times 5. All right. Will my signs, Izzy, be the same, or will they be different?
Different.
Good. And so which set of factors am I going to use?
Plus and minus.
No, but which 1 and 20, 2 and 10, or 4 and 5?
4 and 5.
Good, 4 and 5. Which one's plus, which one's minus?
4 is plus and 5 is minus.
All right, check that. If I add those, do I get positive 1?
Good. Wait.
No. So actually, which one should be my plus?
5.
5 should be my plus, and 4 should be my minus. So Izzy, my final factored answer is what?
X plus 5, x minus 4.
Good. And I didn't slide and multiply, so I don't need to slide and divide, bottoms up, none of that. This is a simple factoring problem. All right? So now, let's go back and look at the denominator. Can the denominator be factored down further? Yes, it's another trinomial with a leading coefficient of 1. So we're going to do our x method one more time. All right? Jevinson, what goes at the top of this x?
2x.
Just 2. Remember, okay. And the bottom? Awesome. I need factors of 15. So 1 times 15, 3 times 5. Will my signs be the same or different? Different. So which set of factors will I use?
You're going to use positive 5.
Okay, so I'm going to use 3 and 5.
Yeah, 3 and 5.
All right, and you said the 5 will be the positive
Yes, ma'am.
and the 3 will be the negative. Okay, so my final factored answer?
Is x plus 5, x minus 2.
Awesome. Now, once everything is factored, now do you see anything that can be simplified? All right, who said yes? All right, Noah, what do you see that can be simplified?
Well, x plus 5 is 2.
Okay, there's an x plus 5 in the numerator and there's an x plus 5 in the denominator. And anything over itself equals what?
1.
1. This is when we can cancel a binomial. When the binomial is in the numerator and the binomial is in the denominator, that is when you can cancel a binomial. Because anything over itself equals 1. So my final answer is x minus 4 over x minus 3. Okay, this is where you should have your aha moment. Now do you see why before you couldn't cancel those binomials? You have to have a binomial over itself in order for it to cancel. Okay, any questions? All right, let's look at letter H. Look at the numerator. Is the numerator factorable? Can we factor it? Why can we factor it? It's a difference of squares. Very good. So this one we can factor pretty quick. Will our signs be the same or will they be different? One's plus, one's minus. Zach Silcox, what's my first term going to be? 2. The square root of 4 is 2, so each one gets a 2. And the square root of x squared? So each one gets an x. Awesome. All right, look at your denominator. Izzy, can I factor the denominator? Yes, I can. All right, so I'm going to factor. I'm going to use my x method. What goes, Jalen, what goes at the top of the x?
2.
Good. -1 goes at the top. And at the bottom, Jevinson, what goes at the bottom of our x this time? -2. So we need factors of 2, and we only have 1 and 2. So Jacob, will our signs be the same or different? Different. And which one's your plus and which one's your minus? Very good. I need a -1, so my 1 is positive and my 2 is negative. So my factored answer, we're going to go back up here to the denominator. Jacob, what's my factored answer? All right, now, does it look or appear, now that everything's factored, that we can cancel anything? I see some yeses and I see some nos. Who says yes? All right, Kennedy, what do you see that you think can be canceled?
2 minus x.
All right, now I want to look at that very, very carefully. All right, she said 2 minus x and x minus 2. Kennedy, here's my question. Look at the numerator. The 2 in the top is positive or negative? And the 2 in the bottom is? All right. The x in the top is? And the x in the bottom is positive. Okay. So according to all of that information, can we cancel those? No. But she's not entirely wrong in her initial thought that it can be canceled. What are those? What's the relationship between the two of those? What would you say? Because they both have a minus sign, but in the top you've got 2 and then x, and in the bottom you've got x and then 2. So they're what of each other? They're opposites of each other. So why can't we cancel them? If they're opposites of each other, why can't we cancel them? We can. But here's the trick. If I have opposites, and listen, the signs have to be the same. The only thing that's different is the terms are going to be in different spots. If I have the opposites, I can absolutely cancel. But instead of it being a positive one, it cancels and becomes a negative one. You say, oh my goodness, Miss Johnson, I don't get it. All right, watch this. Let's take 2 minus x down here. If I pull out a negative 1, if I pull out a GCF of negative 1, what is 2 divided by negative 1? Negative 2. And what's negative x divided by negative 1? Positive x. So now, look at that binomial. Let's rewrite it. Now when I rewrite it, does it match the denominator? Yes. So do you see, instead of making you have to factor out a negative 1 so that you will have the same thing over itself, I'm teaching you a shortcut. If you see a binomial over its opposite, just cancel it. But remember, it's canceling and becoming a negative 1. All right? So it's a shortcut. That's all I'm teaching you. If you look in your book teaches you to actually do this work as part of your problem. I'm not going to make you do that. I'm going to teach you to find the shortcut. If it's a binomial over its opposite, cancel it out, but make sure you cancel it to become a negative 1 instead of a positive 1. All right? So let me go ahead and erase this. What is our final answer going to be? Anybody? Where do you think we're going to put that negative 1? Just in front of the fraction. Put the negative sign, and then you got 2 plus x over x plus 1. And that is your final answer. All right. So it wouldn't be a bad idea at this point in your notes, next to letter H, over in the margin somewhere, write a binomial divided by its opposite is equal to negative 1. All right. I'll say that again so you can write it down because I see you so fervently writing because you really want to get this. Okay. A binomial divided by its opposite is equal to negative 1. That's the shortcut. A binomial divided by its opposite is equal to negative 1. Any questions? All right, example number 2. For what values of a variable or of the variable is the rational expression undefined? Now let's reach back into our memory and let's think about a fraction that is undefined. If we in the past have said that the answer to our problem was undefined, where was the 0? Was the 0 in the numerator or was the 0 in the denominator? If the fraction came out as undefined, or in our calculators it says error, was it the numerator that was equal to 0 or was it the denominator? The denominator. I got one person that remembers. Awesome. Okay, do you guys remember that? If I stick in my calculator 5 divided by 0, it's going to say error. So look at the directions to this section. You set the denominator equal to 0 and solve. That's how you find the answer. That's how you find at what value the rational expression would be undefined. So look at letter A. What is the denominator? Class of letter A. X minus 8. So we're going to take x minus 8, set it equal to 0. And how do I solve for x? Add 8 to both sides. So we know that if x equaled 8, this problem would come out to be undefined. Not sure? Look. Go back and plug 8 into the problem. What is 8 minus 8? 0. 11 divided by 0, every time is going to say error because it's undefined. Now, x can be anything else and you're okay. But x, if it equals 8, that will make your problem undefined. All right, now look at letter B. What is the denominator of letter B? Class.
X squared plus 5x minus.
So we're supposed to take x squared plus 5x minus 6, and we're supposed to set it equal to 0. Where do we go from here? We need to be able to solve for x. We got to find out where this problem is going to be undefined. So what's the only thing I know how to do with this trinomial? Factor. Okay. Actually, I know a couple things to do with this. I also know the quadratic formula. But does anybody want to go use the quadratic formula right now? No. So we're going to factor this. All right. So let's get our x. Janicia, what goes at the top of this x? And what goes at the bottom? Good. Will my signs be the same or different? All right. Factors of, I need factors of what? 6. So 1 times 6 and 2 times 3. Which of those, Janicia, am I going to use? All right. But I'm going to subtract. Good. I'm going to use the 6 and 1 because subtracting them is what's going to get me a 5. Which one's plus and which one's minus? Very good. So when I factor this, Janicia, what do I get? Good. And don't forget, that's all set equal to 0. So am I finished? No. What's my last step?
Set them both.
Good. I'm going to set them both equal to 0, and I'm going to solve. So, Zach, Silcox, how do I solve x plus 6 equals 0?
Subtract 6 from both sides and 8. Is x equals 6?
Not 6.
Negative 6.
Negative 6. All right. And Ellie, x minus 1 equals 0? Add 1 to both sides. And x equals 1. So, when x equals 1 or when x equals negative 6, my problem would be undefined. Are there any questions on this lesson? All right. That is 11.4.